Hi, I'm Roberto Interdonato. You may remember me from other presentations from yesterday, but okay. The work which I will present today, it's a joint work with other colleagues at CIRAD, Jeremy Bourgoin and Kenty Grisland, but also with Matteo Zignani and Sabrina Gaito from University of Milan and Marcus Giger from the University of Bern. And it's a work about large-scale land acquisitions. So, first question, what is a large-scale land acquisition? It is what the name says, so basically. So it's a deal between two companies, which consists in buying large quantities of land. When I say large, in general, we can think about quantities over 200 hectares. And it's a global phenomenon which saw a big increase in recent years due to a lot of different reasons, like increasing in demand for biofuel, but also increasing food demand and change of dietary habits, for example, in Eastern countries, and a lot of collateral reasons. And it's a phenomenon which creates some problems because land acquisition is a kind of nice term, but in a lot of cases this can be called land grabbing, like in the picture behind. So this can create conflicts with the local populations. Very often they are not informed about what is happening, for example, in their village and things like that. There are problems concerning the governance, people rights, and a lot of other stuff. So it's a phenomenon that is studied at global scale from different organisms. For example, there is the Land Matrix project, and there is also the GRAIN project in indexing and collecting information about this phenomenon. In this case, we will work with the data coming from the Land Matrix Initiative database. This is an initiative launched in 2009 and provides multi-source and open access information about land acquisition. There is a website containing all the information, landmatrix.org, which is really interesting. There is a lot of maps and interesting things to see. And the information is coming from heterogeneous sources like national observatories, government data, press, voluntary contributions, scientific publications, a lot of heterogeneous sources. And yeah, it's related to land over 200 hectares that is being leased or sold. And at the moment it contains 2,800 transnational deals and up to more than 4,000 if we include domestic deals, so deals which happen inside the country. And it's already a lot of data, but it's really not complete. I mean, there are some countries that are not covered at all because it's really dependent on the sources, you see. So there are some countries which are not very prone to give information, it's difficult. So there's already a lot of data, but it's really not complete. So what is the goal of this work? It's modeling the information about large-scale land acquisition in a land trade network and provide an analysis consisting of a centrality-based analysis and an analysis of network motifs, okay? So how do we model our land trade network? In this work, we will model a network between countries, okay? So let's keep in mind the fact that the data in the original database, it's on the single deals, okay? So each entry in the database, it's a land acquisition deal between two companies. So this can also include some intermediaries. So there are parent companies, operating companies, there is the target country, there are a lot of attributes. I think that for a single deal in the database, you have something near 200 attributes describing a lot of different characteristics of these contracts. But in this case, we will model the information by aggregating by country. So each node in the network is a country, and we will put an edge between two countries if there is at least a deal involving a company from one country which has a deal, which has as target country the other node. It's rather intuitive. I don't know if it's clear my explanation. So it's just a network of countries. In fact, it's not big. It's 160 nodes in this case. And the edge weights model the total size in hectares of the deals between the two countries. So the sum of the size of the deals between these countries. And obviously it's a directed network. And we take into account only the transnational deals, because for network purposes, the domestic deals are not interesting for this analysis. And here you can see a picture of the network. It's not very clear, so it's better to see the spatialized one. It's much more interesting. So this is the land trade network. In this first picture, we see node sizes proportional to the total weighted out degree of each country. So the total size of the land acquired by each country, okay, in hectares. And it already says different things. For example, we can see a clear north-south divide, you see, in land acquisitions. You can see that the biggest investors are the G20 countries. You see all these balloons in Europe, USA, Canada, etc. And you can also see the importance of BRICS, so the emerging economies like Brazil, Russia, India, China, and South Africa. They are also big investors in this moment. And this is the opposite representation of the network. So here we have a node size proportional to the ratio between incoming deals, so land sold by each country, always in hectares, and the total quantity of agricultural land for each country. So we can say that it's a weighted in degree normalized by the quantity of land available in each country. And we can see that in the south, in southern countries, land deals account for a really large share of the total land. We have some extreme cases, like in Papua New Guinea, for example, the acquired land is up to 97%. This means that it's an whole country sold to, we don't know, someone else. Other cases in Liberia, in Malaysia, with high percentages of acquired land, over 70%. So, I mean, there are a lot of analysis that can be done about this. I mean, qualitative analysis about social phenomena, economic phenomena, governance, and how these deals are creating opportunities, maybe ensuring food security with these investments, but also creating basically neocolonialism in such countries. It's a really complicated phenomenon. And another analysis stage is this one. This is an heat map which represents the Pearson correlation between basic centrality measures, so in degree, out degree, and betweenness of the land trade network, and some country development indicators. So biocapacity, which is, we can say, basically the quantity of land that can be cultivated in a country. Governance indicator, corruption perception. It is important to say that corruption perception is a rank. So at 1, it's clean. At 100, it's the contrary. It's the opposite of what I said. I mean, at 1 there is a high perception of corruption, and at 100 the country it's okay, I would say. Human development and growth, national income. So what can we see? That, for example, land deals are directed towards countries that have low development rates. So this kind of confirms the second map we saw. So we have an in degree which is not correlated to all these development indicators. And conversely, I mean, countries acquiring land are highly correlated with all these development indicators. So this confirms what we saw in the maps. And also we can see a correlation between biocapacity and betweenness. So we can say that there are some countries that act as a sort of flow hubs in the network. So they sold their land and they acquired land somewhere else. It's a kind of complex phenomenon. So we don't have just investor countries and target countries. We have also a lot of countries which are in the middle of this thing. They both acquire and sell land. So to deepen the analysis, we resorted to network motifs, which already saw this morning. So induced subgraphs that are statistically significant with respect to random connections in a network. We analyzed all motifs of size 3, 4, and 5 using the G-trace algorithm by Ribeiro and Silva in 2010. Here we see some example motifs. The motifs are directed. Here the arrows are not really visible, but okay. And yeah. we'll just skip details, so generate 100 random graph. We use the z-score to assess the statistical significance, and we focus on over and under represented motifs. So let's come to analyze some example. So as also Henri said, I mean, when we do network motifs analysis, you come out with a lot of motifs. So do an extensive analysis of all the motifs, it's actually not possible. So we will just show an example for each motif size in this case. So for example, this is a motif of size 3, where we have 2 investing countries and 1 target country. This motif has a frequency over 5,000, and this is just an example of one of the many phenomena of this kind. We see France and China investing in Vietnam in this case, with this big investment about agriculture and the big investment about mines from China to Vietnam. This is a motifs of size 4. Here we have 2 target countries, purely target countries like Indonesia and Macedonia. And we have 2 countries that are both investors and targets, so India, Sri Lanka. And here also we can say this enormous investment from Sri Lanka to Indonesia with 128,000 hectares of food crops. And also other little investment coming from India to Sri Lanka, for example, in tourism or agriculture. And for the end, this motifs of size 5, which is even more complicated, with 1 target country, Nigeria, 1 investing country, Japan, and 3 countries that are both, so investors and targets. And this is interesting to see how there is a big investment from China to Paraguay, acquiring a lot of hectares of mines. But at the same moment, we have Paraguay investing with an investment of over 77,000 hectares in Nigeria. So this is one example of the flow hubs we were describing before. So we have Paraguay, which sells a lot of land, but at the same time acquires thousands of hectares somewhere else. And this is all for now. Next steps, extend the analysis to other characteristics. I mean, the database is very rich, but it's also very noisy. So it takes some time to analyze the data, clean the data, aggregate, etc. But we may take into account implementation status. I mean, if a deal is in operation, it's abandoned. There are a lot of abandoned deals, contracts that are signed and then nothing happens. I mean, there is a lot of land which just stays there. Analyze the network based on the companies. And this is also interesting because we have the companies, so we can create a network with that. The problem is that different companies or companies with different names may belong to the same owner, so this needs some pre-processing to be really significant. Temporal analysis, and also extract additional information from other sources like newspaper, websites, but also data from investigative journalism, like, for example, crossing the data about the companies in the land matrix database with the companies which appear in the Paradise Papers and Panama Papers to see if there is some connection in this kind of financial transactions. And it is everything for now. The full paper will be also presented at Complex Networks in Lisbon. You will find the paper in the proceedings too. And that's it. This is my last presentation for this Marami. And questions?
Any question? Did you try using software that are based on ergo models, which sociologists use for such kind of situation? They analyze this kind of motifs, and then they have a very complicated machinery that makes...
No, okay. I'm not familiar with it because the motifs part of the complexity has been done by Matteo Zignani. He was supposed to be here. He's not here because he's sick, but we will check it. Okay, thank you. Yeah, sure.
It's a very standard way, at least in sociology, to look at motifs in the sense you...
Okay, sure, we will check it.
Especially when they are directed.
Okay. Sure, thank you.
And just another question, do you have some notion of duration of the link? Your interaction, it's basically a
yes,
company that asks...
we have temporal information. I mean, we have the starting date of the deal, We have the implementation date. Yes, we have
Yeah,
time
so,
data. This depends. Obviously, it's sparse. I mean, you have not the guarantee that there is this information for all the deals, but yes, we have temporal information. Yeah. Yes.
I'm wondering if you can have the same land appearing multiple times in different transactions.
Yeah, also, but it's in fact this can also obviously bias the sum of the hectares and everything else. But
if you take that into account, because if you have two countries that the same land over and over again.
yeah, this is part of the subsequent analysis that we'll perform. It's this can happen, obviously. Okay. In fact, we ended up with this kind of thing. Like if you do the sum of the hectares of land, this may be higher than the total land in the country. And you see, how can this be possible? Yes, because obviously the land can go back and forth. But it's not easy because we have some information about the geolocation of the investments, but it's a sparse information, so it's not really easy to understand if the land is the same land or not. I mean, it's.
So you don't have an ID or something like this?
We have some information, but it's not complete. For some deals, there is some kind of extremely precise geolocalized polygons, okay? And for other deals, it just say, okay, it's near a river somewhere. And so it's not easy. But yeah, you're right, sure. Yes, Milo?
In the non-matrix project, if you have, say you have polygons behind each transaction, is there a part of the project who is getting interested in what do they do with the polygon?
Yeah. There is another part of the project which is more the remote sensing one, to characterize the implementations by remote sensing. So really look at what happens in the farms, what happens in the implementation. So we have information about that, but again, it's not always precise. So we may see agriculture, food crops, but yes, there is a part of the project to characterize this. Sure.
Any question? So I have a question. As you use information of different resources, heterogeneous information, what type of graph you generate? Simple graph or a single layer, for example? Or
But this depends on the information we can get. For example, if we will be able to create, not to create, I mean, we already have it, the network from the Panama Papers database. And then it will become a sort of bi-layer network, if you want, if we arrive to link the companies in the land matrix to the companies in the Panama Papers. So you analyze two layers with different relations between the same companies. Or obviously this will be a subset of the companies in the land matrix. Or, I mean, if you want to use heterogeneous information to enrich the information that is already there, that may be just enrich the actual network, so enriching the database. So this depends on the information and on the use we will get to make of it.
more questions?